Now we want to look at how would we generate the unit circle. This big circle down here is the unit circle. And the unit circle quickly gives us the different sine, cosine, and tangent values for known angles. Specifically angles that are 30, 60, 90, or 45 degrees, or a relationship in each of the different quadrants that are related to the 30, 60, 90, or the 45 degree triangles that you studied back in geometry. So we can see right here a couple facts about the unit circle. It has a radius of 1. Each point on the unit circle is a unique x and y value. X values are cosines, y's are sines, and the values of sine and cosine are tied to the angle created on the unit circle. Now before I go and fill out this unit circle, let's look back at where these values are going to come from. So if you could flip to the top of page 49 to start with, where these values come from. And I'm going to not necessarily take the first ordered pair as an example, but let's think back to geometry. And if I had a 45, 45, 90 triangle, 45, 45, 90 triangle, and we'll say that's 45, 45, 90, we knew that the sides were 1, 1, square root of 2. Here the hypotenuse has a square root of 2. When we're working with the unit circle, though, we need the hypotenuse, or what's going to turn into the radius on our unit circle, to have a value of 1. So normally my value here was square root of 2. If this hypotenuse has to have a length of 1, the way I force that to have a length of 1 is I'm going to divide everything by the square root of 2. And I'm going to divide all these sides by the square root of 2 since I want to keep the same proportion. And if I do that, this becomes square root of 2 over square root of 2. This becomes 1 over square root of 2. This becomes 1 over square root of 2. Which means my triangle then is going to have the dimensions, a hypotenuse of 1, an opposite of square root of 2 over 2, and an adjacent of square root of 2 over 2. So when I'm talking about a unit circle, I'm going to be concerned with square root of 2 over 2, square root of 2 over 2's, and not 1 and 1, even though that's what you learned in geometry. So the first piece that we're going to have is we're going to have square root of 2 over 2 is one of the values we're interested in. The other value that we're interested in comes from the 30, 60, 90 triangle. And if we do your 30, 60, 90 triangle, let's just do one of these. We'll say this is 30, this is 60, this is 90. The relationship is 1, 2, square root of 3. So my short side was 1, my hypotenuse was 2, and then my opposite side, or the side opposite the 60-degree angle, was square root of 3. But once again, my hypotenuse, when I'm talking about the unit circle, has to be 1. Right now it's 2, so I'm going to divide all these sides by 2 in order to get the values I want. So when I'm talking about the unit circle, and I've got a 30, 60, 90 triangle, the values I'm going to use are 1/2 square root of 3 over 2 and 1. So when I'm dealing with the unit circle, I'm going to be looking at square root of 2 over 2, 1/2 square root of 3 over 2, and of course 1, since that is the unit. So I just need to have these three values down, and this is where they come from. It's all 45, 45, 90, and 30, 60, 90 degree triangle relationships. So coming back to page 48, we want to start filling in this unit circle. And I'm going to start with the first quadrant. Right here, the center is at the origin 0, 0. And I've stated that the unit circle right here is going to have a radius of 1, which means every single one of these spokes has a distance of 1. The easiest pieces for me to fill in then are the ordered pairs that are exactly 1 unit away. So if I go here along the x-axis, my ordered pair is going to be 1, 0. I'm 1 unit out in the x direction, no height. The other one I know is 1 unit up and 0 units over, which is 0, 1. The third one that I've got is off to the side here, -1, 0, going in the negative x direction. And then finally the last one is going to be 0 and -1. And with those values, we can also fill in the degree and radian measures. This right here is going to be 0 degrees or 0 pi. Up here, we know we've got a 90-degree angle. If we use this as our initial side, this is our terminal side, 90 degrees, or pi over 2. The third one over here, 180 degrees, or pi. And then finally at the bottom here, 3 pi over 2, or 270 degrees. So those are the basic pieces of the unit circle that we need to start with. All these other values now are all based off of the 30, 60, 90, and 45, 45, 90 degree triangle. And there's a nice pattern that we're going to follow to quickly generate the unit circle. I know that my 3 values that I'm interested in are going to be square root of 3 over 2, 1/2, and square root of 2 over 2. Those are going to be all the values that I fill in for my xy ordered pairs. So to start off, I know every single one of these denominators for the fraction are going to be over 2. You can see that's because all these fractions right here are all over 2. Now the question is, which order am I going to put them in? And the way we look at it is we look at our numerators and we're going to put them in either increasing or decreasing order. So right here, starting with 0, I can see my y value is 0, my x value is 1. That means for the y values, I want to count up from 0 to 1. That's increasing. 0 to 1 as I go around the unit circle. So that means the order of my numerators is going to be 1, 2, 3. I start with 0, my y ends up at 1, which means my numerators have to increase. And we said that our 3 values are going to be square root of 3 over 2, square root of 2 over 2, and 1/2. So I've got to make sure I put square roots up there. If I look at 1 and 0 here for my x's, I can see those are decreasing. From 1 to 0, I get smaller. So that means my unit circle is going to go square root of 3 over 2, square root of 2 over 2, and 1. 3, 2, 1. I'm decreasing. And then I can fill in the inside my different values. 30, 45, and 60 degrees, which corresponds to pi over 6, pi over 4, and pi over 3. Really what I just did was I have 3 different triangles that I created inside here, and I gave a distance on the unit circle that each of those coordinate pairs are. So for example right here, this 30-degree angle, if I were to imagine, there's actually a triangle inside here that's a 30, 60, 90-degree triangle. And if the hypotenuse is 1, that means my adjacent side here is square root of 3 over 2, and the height is 1/2, which is why I've got square root of 3 over 2 and 1/2. Same thing here with the 45-degree angle. I could create a triangle right here, which then gives me my square root of 2 over 2 and square root of 2 over 2, because this right here has a length of 1, which is what we found out at the beginning. Same thing with the 60-degree angle. In terms of this, you can see everything is positive. Both my x and my y values are positive, and none are negative.